So what's the most difficult part of AI, of building things? Let's talk about that today. A lot of people are like working in AI or want to work in AI domain. But what's actually most important things and the hardest things in AI when you build a product, AI product, or solving the real AI problems? By the way, if you would like to receive more AI related videos like this, don't forget to subscribe. So, in my opinion, and also a lot of people's opinion, if you really work on this for a while, you will find out evaluation evaluation is really the hardest part of AI problem when solving the real world problems. Why? Because, for example, if you want to do a self-driving car, right, then it's not that hard to write the program, build an AI, build a model. They can let your car to drive on the street, on the highway for like 10, 100 miles, 1,000 miles without a human engagement. It's not that hard. But what's really hard thing is that 0.0001% situation that you won't encounter unless you really run for 10,000, 1 million miles. So that kind of things is like when you build algorithms, it's unless you really run like 1 million miles, you won't be able to evaluate it, to know how good this algorithm is. Or you twist something in this AI, driving AI algorithm. You solve certain problems, but you don't know what kind of other problems you create. So this is one example in self-driving car. So let's just take another example. Question answering. You can definitely do good on your test data sets. How we do like question answering is we will create training data sets, we create a test data set, and the model will learn from the training data set. Model will evaluate model in test data set. Model usually can perform quite well, so you select the model, they perform like achieves 80% accuracy. But when you really deploy your model to the users, ask any kind of problems that you didn't expect, you never expect. Then how do you evaluate those your model in those unexpected out of domain things? It's really hard. It's really hard because model neural networks are really good at fitting data, learning from training data. It's like it's fitting very well in the training data, and usually your test data is like have your test data has the same distribution as your training data. Neural network can do that very well, but you in the real situation, your user input will be very different from your training or test data. So this is the difficult part in NLP. And in a self-driving car, it's a totally different situation. You can maybe do well, but similar. You can do well in this simulation, but in the real world situation, there will be so much like edge cases you never expected before. Same thing with NLP, and things goes on like speech recognition. You can do very well in your training data. Your training data maybe a certain like West Coast U.S. accent. In the real world, people from let's just say in the U.S. native speakers. Okay, there are still a lot of dialects variations in the U.S. If people from the Midwest, from New York, they have different accents. Then your model originally doing very well on your training and test data because your data are from the West Coast accent. Model error rate maybe like 2%, but when your users has a slightly different accent, it's still American accent, but slightly different. Then your model maybe performance error rate like increase from 2 to 10%. So it's really hard. It's like how you evaluate your model properly and to handle those out of distribution problems. That's really hard. And there are also two levels of like evaluation difficulties. One is out of distribution problems, and some other problems that you don't even know how to evaluate. For example, you want to build the AI that can solve. They can be a lawyer, so you can argue in a court. But how can you evaluate that? You can't just build a classification data sets, and your models can classify all these problems, need to have this answer. Debating in the code, there's no standard answer. It's very, very hard to evaluate. You cannot just deploy your AI in the code directly, right? So how can you build a system that can evaluate your debating robot? There will be a tricky one because this is really open-ended. So when you really work in an industry, you are solving a lot of problems like this. You won't be solving like sentiment analysis, sentiment classification. They kind of well-defined problems. Most of the time, you won't. You are solving these kind of very open-ended questions. So that's why I think how to find out evaluation methods is the hardest part. Once you find out, you can iterate very fast. For example, for sentiment classification, you can build up your model very quick, and to check if your model can perform well on test data, on development data, or training data, so that you adapt your model, you implement different model architectures, find out which one using different hyperparameters, see which one performs best. So you solve certain problem, you can at least perform well on a test data. Then the next problem you have is out of distribution problems, which is a smaller problem. The biggest problem is like open-ended problems, like how you evaluate debating robots, right? So you basically how you evaluate a consulting robot. They can replace consultants. How you evaluate that? Maybe it gives a lot of suggestions to a company, but how you know those suggestions are good? Even for humans are very hard to evaluate humans in those kind of domain. So how can you even evaluate robots? So those are the things that really work. So the takeaway is evaluation is the most difficult part in AI, and there are two kind of evaluation problems. One is when you evaluate in your test data, it doesn't mean your model can perform well in the real user input or real scenarios, because there were a lot of out of domain, out of distribution data that come in and you don't know. And I already give you a lot of examples, right? And the second one is this problem is too open-ended. You don't even know how to evaluate. You don't even have the test data. You don't even have golden test sets. So this is the second hardest part, which is the most difficult part, I think. So that's my opinion how to build an AI product and what's the most difficult part. So if you would like to receive more AI-related videos like these, don't forget to subscribe. I make this kind of video every week. And other than that, take care. I will see you next time.